Hey everyone, what's going on? We're back today with everyone's favorite controversy, 12-volt high power. So, NVIDIA has so far failed to address the leading cause of failure, which is the complete and utter lack of contact area on these cables. Now, the issue with this is that you have 2 dimples or 3 dimples each side nowadays, but why would you put dimples in a place that the connector's not even going to touch? So we're going to examine today how we're going to fix this issue, what it's caused by, and if 8-pin is even as bad as they say it is for power delivery to begin with. Now, we'll be examining what kind of diameters we're looking at least the square kind of diameters for contact area, and how thick the actual cable itself is. Now, there's 2 portions to this. First of all, the contact area of the cable must be large enough for 600 to 900 watts to blast through. Because remember, we have transient spikes of up to nearly 1000 watts on the 4090. On the 4090 Ti, it's going to be even worse.
GPU power for the 3080 and the 3080 Ti are now listed at 320 and 350 watts. And that's before accounting for custom V-BIOSes. You're looking at potential transient spikes upwards of a kilowatt. That's crazy.
Okay, so the issue is that your dimples, which are, remember, 2 to 3 on each side, which is a spec right now, is going to be, one, extremely hard to implement correctly because your pin size is only about 1 millimeter thick. If you don't know how bad it looks, this is about 2 millimeters on the EPS 8 pins, and on the 12-volt high power, these things are about 1 millimeter across in actual contact in the actual pin diameter. So we're looking at basically exactly half the size of the EPS 8-volt, EPS 8-pin versus the EPS 12-pin. Why would they do this? Well, you asked me, and I really don't know which engineer came up with their qualifications to those up on the job. But let's have a look here with our good old calipers here. Very analog calipers. We'll try to get a readout on this. Get it as close as we can. Alright, so here we can see that the pins are kind of sitting on the edges of this caliper. It's not very exact because I can't really find any tools to fit into there. But that is an entire millimeter, guys. 1 singular millimeter of contact area per pin. Now there's 1, 2, 3, 4, 5, 6, 7, or 12, sorry. 6 and 6 ground, 12 volt. And you have 4 pins here for signaling, which are completely and utterly pointless in this case. And we're expecting the 4090 to pull upwards of 600 watts all the time. Maximum peaks of up to maybe 700-800 watts if the load balancing between the motherboard and the connector is not up to scratch, or if the motherboard is, say, a lower end board that can't provide enough power to balance out and it will draw more through the connector. Now the issue being, if you do that, then suddenly this is not designed to take more than 600 watts. And if the transient of the card itself is about 1000 watts maximum, the slot itself can only take about 120 to 150 watts. Now, if this connector can only take 600 watts, automatically you already have a power problem at 750 watts. Now, you transient even higher than that, you're overdrawing on both the motherboard or the connector and or both. So now you have a fire hazard not only with the motherboard, but also the connector itself. But most likely, by way of design, it's going to all draw through the connector itself and have power excursions, say, of upwards of whatever 1000 watts. And now here's the other concerning thing. You cannot, I repeat, you cannot use an ATX 2.0 spec power supply that is less than about double what your system power consumption TDP is listed as. So if you tried skimp any less, so say if you try to use, I'll put in an ATX 2000 watt, it's going to burn the power supply after like less than a year, right? I had a customer come in with this RTX 4090 to begin with. So this 4090 has actually been used once by the customer and it's working perfectly. It's an RTX 4090 Aorus, I think, Master or something, but it's a great card for what it is. Although the issue being, it has 1 single EPS 12 volt, or 12 pin, sorry, 12 pin 12 volt and that is really, really insufficient to draw over 700 watts of transient to 800 watts of transient through. Just the part here alone, never mind the slot, which will be maybe upwards of 150, 200, maybe even more when you hit transient loads. Now, if this is the case, why don't we put a second connector on NVIDIA? It's not that expensive. Just put 2 EPS 8 pins here, and that's gonna blow this out of the water. In fact, the contact area on this, I crap you not. Okay, so if we take the area here, it's pi r squared, yeah? So we get the radius. Now the radius is double. Now, we'll prove that to you, that it is actually double the contact area. You see these, if you look inside the actual connector itself, it's really hard to see, but you can see there's 2 dimples on the inside of that. And if you look at it just very roughly eyeballing, you see that the EPS 8 pin has about a, let's see, 0.6 mils. A 0.6 millimeter dimple on some really, really cheap design here. Now, this dimple here on this thing is 0.3 mils. Guys, 0.3 millimeters on the EPS 12 pin is absolutely a scandal that this is even allowed to exist without being declared a national fire hazard. Alright, let's say for the benefit of a doubt, because I really can't get the calipers down enough, let's say it's going to be 0.4. Or more likely, it's going to be 0.35 from what I can see here on the analog scale. Now, let's say, for example, we give it the benefit of a doubt, yeah? So, if you take 4 and you square it, so we get pi r squared. Sorry, it's been a while since I've gone to university in high school. Well, yeah, pi r squared, yeah? So now you have, say, 16 millimeters squared versus, now on this, that's 16 mils here, and this was 0.6, remember? So now if we have 0.6 on the contact dimple here, and this becomes, wait, okay, so 0.6, it would be, let me square that, it's 36. So 0.36 millimeters squared versus 0.16 millimeters. This is more than double the contact area. I'm not capping. This crap 6 pin here is double the contact area per dimple than the EPS 12 pin per dimple. Think for that for 1 second. This is rated for about 150 watts. You have the equivalent of a single 6 pin power connector powering the entire 4090. Please tell me how in any way, because look, the weakest link in the chain is the physical connection here between the metal and the metal, yeah? So you have dimples on 2 sides, and of course you have 2 dimples, but if you have any kind of mechanical knowledge, you would know that if you put a leaf spring in like this, and you have the dimples on, say, over here and over here, if you put any more dimples down here, these inner dimples will touch, but the outer ones will not. So these are going to be really hard to touch anything with. Even if you put 3 dimples on there, it's not going to do anything. The only thing you're going to do is potentially, just push it even further apart so you have even less contact area. That's worse. So you see that the connector really is a bit of a C shape. You have a dimple over here and a dimple inside and maybe another further one here, a third one, if you're really that crazy. And your tolerances are going to be insanely tight if you want to get this fire free, right? You have to get this one really, really raised, and then the next one is a bit shallower, and then the next one's like nearly next to the wall. So that will be your manufacturing tolerance in a Chinesium factory, say manufacturing thousands of these a day, non-stop, in machines that are probably 10 years old by now, and you're going to be mass manufacturing this kind. It's not handmade. This kind of thing is crazy to quality control to even begin with. Now this, if this is too small, you're going to have a fire, because remember, the surface area is going to be really causing issues if you shrink it down further and further. You want the surface area to at least be the same as the, the 6-pin EPS. Very, very low bar to clear, guys. 6-pin EPS, not even 6+2 yet. We have hit the 6-pin EPS, and we've already gone over the 150 watt to 200 watt spec. There is no way you can put 3 times peak power through this thing and not expect this thing to burn, right? This thing can probably take it better than these, because now, remember, you got multiple chances of weak links in the chain, whereas in this, you only have 6. You have 12. One of these or 2 of these is badly made, that's going to start a fire. It doesn't matter if the rest are well made, it matters if 1 or 2 are failing, right? There's no redundancy. Now, remember, the latest spec for the RTX 3090 and the 3090 Ti was at least 2 8-pin connectors here. 8-pin EPS, yeah? Very, very common connector, very reliable. No one ever really complained about this except for the miners who are hooking it up to SATA, which ironically, this is part of a mining kit. So, this is, well, pretty much useless. I mean, you see, even this kind of setup would work because at the end of the day, there's really not too much issue. Your number of ground cables and number of supply cables are nearly exactly the same. So there's really no point in putting any more than, say, 1, 2, 3 and 1, 2, 3. So this is what they're trying to condense down into a EPS 12 volt. Now, the big issue is, if you halve the surface area, how is that even going to match a single 6-pin connector? There is no way you can get a single 6-pin connector to match, right? So in order for this to work, you'll have to have at least 1.5 times that diameter there. There is no way you can have a pin 1 millimeter across in diameter, pi r squared, yeah, and expect that to work. You're not going to fly. You're going to cause a fire, someone's house is going to burn down, and they're going to sue you, and you're going to lose millions. Right? It's not going to work. This is terrible, terrible idea. And all your manufacturers, OEMs like me, are going to be pissed as hell because they cannot get a working video card or a working gaming system in the hands of customers for their peace of mind. Now, if I have to resort to going to JCar to buy a $10 tube of silicon conductive grease and then fiddle with this for 30 minutes to get the grease into the connector with a pair of tweezers and a lot of patience and a lot of skill and good eyesight, then you're expecting too much from your customers. If you can't plug and play a connector, look how easy this is. Look, oh no, I'm 50-50 vision, yeah, I can't see any, oh, it's in, that's it. You can hear the click, it's loud, it's easy to put in, there's really no tolerance issues, and it's very, very hard to dislocate, and yeah, it's perfect, it's fine. Now, the issue herein also lies with the fact that you're using a C connector. A lot of these are split C connectors. Now, they only have the dimples on these sides, but they don't have any dimples on this top and bottom part. They need dimples on this top and bottom part, and I understand it is very hard for the manufacturers to put them in. If you don't put dimples on the top and bottom part, your contact area is going to be less than a single EPS 6-pin. You are throwing lives away. You are absolutely going to you're tanking your insurance, your profits. You're going to have to recall the entire 40 series. This is where we at. This is what NVIDIA is doing to their customers. Who pushed this through? How did this get through QC? How did this even get through the engineering team? And how did this get through the shareholders and the blokes at the top, like Mr. Jensen Huang, right? Just for a second, understand that you're tripling the heatsink size. That's fine. You're doubling the heatsink size from the last generation and tripling it compared to the 10th gen. But you've halved the size of the connectors. So just for example, look at the size and the distance as well of each pin will allow more thermal mass to spread out, or more thermal peak load to spread out between the connectors and not create any hot spots between the connectors themselves. Or say if 2 pins are getting hot, the middle one's going to be the hotter one, right? And if that one gets the same kind of heat as well, the entire center area is going to melt first, right? That's how heat really conducts through each other and affects the areas around it. Now, if you get this kind of thing, now automatically one of these 8 pins is going to equal the EPS 12 volt and exceed it in spec. absolutely going to exceed that. Now, obviously, this is not a soldered cable. If you have a soldered cable to the actual connector itself, not crimped, then it's going to have a lot more power capability. And if you had a gauge that's good enough as the EPS 12-volt gauge, then of course you wouldn't have any issues drawing upwards of probably 300-400 watts through this at one point. But herein is the problem. Why do we have one single connector to drive an up to 1000-watt transient card, a 4090, not even the TI, whereas you should be putting at least 2, if not 3. And this thing is the same size, the exact same size as a single 8-pin, which matches it in the current loading capacity at the connection point, if not exceeding it. Like in some cases, if you have bad tolerances here, these are 1mm pins. If you have bad tolerances and it's, oh no, it's a tiny bit too small, it's 0.9, right? It's not 1.0, or it's slightly out of spec. Maybe we missed a dimple or two in the pressing factory at the sheet metal plant, right? Then you have an issue. It's going to blow up. And now who's going to be in trouble? The retailer, the OEM, the system builder, and then NVIDIA itself, and the shipping company. Everyone has to fork out. This is an absolute waste of money, time, effort, and just a complete waste of brain cells. If you're me, don't buy the RTX 4090, don't buy the 4090 Ti, send a message to NVIDIA, this is not okay. This is not how you do engineering, this is just basic math here. If I, a grade 12 graduate, yeah, with a half a degree in mechanical engineering, not even finished yet, at wherever, can figure this out with just a pair of calipers and a bit of metric measurement. What about the blokes who have 10, 20, 30 years of qualifications in the silicon industry, in the computer industry for that many years, and they can't figure out that my 8-pin can punch through more power than this 12-pin EPS? You got brain damage. There's something wrong with you. Whoever let this through, fire them. If it's Jensen Huang, you got to get rid of the bloke. There's something wrong with you if you think this is doing less than this, because this, I guarantee you, will do exactly the same as this. Because even looking just at the size, I mean, it's probably even, it's slightly smaller, to be honest. Yeah, it's just a little bit tad smaller than the EPS by a couple of mils here, maybe like one tiny connector point. So I've got 3-4 millimeters smaller. But this will carry, potentially, if you made this well enough, this would carry better current and more current than this. Like, look, your pins are more spread out in this case. Like, vertically, it's way more spread out. You've got a whole, like, 3 mils of distance here between the top and the bottom. The bottom part of this and the bottom part of this is nearly 3 millimeters apart. So, of course, you're going to have a lot less of a center hotspot in the middle, and that's going to really carry some power for you. So if you really wanted to cram 1,000 watts through that, or like even up to 600, 700, 800 watts, this thing will probably take that peak load. No problems. Yeah? Put a couple of caps and whoop-de-doo. Yeah? You could even potentially put a heatsink or a fan, right? That's blowing air down onto this kind of thing. Now, I do recommend as well, if you own one of these, because this thing has pins at the back that are exposed, right? This is not the entire connector. If you turn the fan on as much as you can, just keep the fan spinning. Don't let the fans idle, because when they idle, the pins of this EPS is not getting cooled. You need to cool the EPS connector by cranking up the fans, or else it will start to overheat and it will burn. Why? Because NVIDIA doesn't know how to hire engineers that are qualified, or someone at the top has overridden the qualified engineers and made a really, really bad call. Maybe on purpose, maybe by accident, who knows. Now, I'm probably not going to get sponsored by NVIDIA at this point, but this is critical need to know information. This is just really basic math, guys. Come on. You do not need to go get a degree to figure out pi r squared, right? So a circle, or even just a normal, rectangle, you square the diameter or you square the radius, and you're good to go. Same exact thing. It's absolutely astounding what you're doing. At the end of the day, if you are halving the area per dimple, you cannot fly. Get some of this stuff, and I will show you now how to apply the carbon conductive grease to solve this problem, at least temporarily, until NVIDIA can recall their cards and get everything working again. We are going to find the bendy bit, and we're going to start cranking in some conductive carbon grease. Now, careful, you want to have this at the edge of a table or something so you don't accidentally spill it all over the PC. Just stick your tweezers into here, grab a little bit of the paste, and this needs to be a bit surgical, by the way. This is not very easy stuff. You have to make sure that you insert some of the paste into the connector, but not to the edges of the connector. Just cram it in around the top here, and when you actually crimp the connectors together by closing them, the action of pushing this down is going to break apart any extra bits that you've got on the edge here. Now just be careful not to put too much, guys. A little bit goes a long way in this kind of application. We don't really want much at all. We just want enough that this will not be an issue. And yeah, just have your wits about you. Make sure you do this right. And so we got one connector apply already. Don't put any force onto the split connector there, the metal bit inside, because you don't want to put any force on it. If you put force on it, you're going to split it apart. If you split it apart, then you're going to have issues because the connection is going to be compromised. So you're going to dabble a little bit into the connector itself. You can run a bit, if you have a flat tweezer, you run a bit over the edge. Just keeping it inside the connector and not going outside the connector place. And be very, very, very surgical with the amount that you're putting in here. I'm putting a large blob on the end of this because I can control it. If your hands are shaky like mine after not drinking enough water, then you best be careful. Now you don't need much, you just need a bit. And yeah, this, not only all of that I've just been blabbering about, but you also have the limit on the amount of insertions. 15 insertions on this thing, they say, that they can potentially guarantee, which is horse because even one insertion is going to cause you issues. In fact, reinserting it might actually be better because now you're spreading the dimples are going to be kind of shaving until the surface area increases. And then you'll have more contact area than the first time you've inserted. So NVIDIA's recommendations are just flat wrong at this point. Think about it. If you sand down the mound, right, the little dimple, if you don't bend the cable a crazy amount, like more than 2 millimeters according to NVIDIA, then you should be good to go if you just reinsert the cable a couple of times. But I can't recommend that. Don't do that because I don't really know if that metal that they're using is copper or steel or some different alloy that can even withstand mechanical cycle loading. Like this could be some really, really brittle metal or some really ductile metal that doesn't have any elasticity and just turns into the next shape that you put it to. It's not even like coated with anything. You'll be lucky if it's silver coated. You'll be even luckier if it has gold on it. But alright, so for the 1000th time, I've got everything set up. I've lost 2 huge segments of footage already. That's kind of stupid, but it's just the way it is sometimes. Clearly, if you can't even get the area right on the dimples of the connector, and you're running this thing here, the equivalent of a single 6-pin cable, you're going to have issues. That is by default. If you need to tell the customer to, you need to apply carbon paste to the connector, otherwise it will catch on fire. And also, if you bend it more than 2 degrees, it might catch on fire. And also, if you plug it in, it might also catch on fire. If you plug it in 15 times, then yeah, you avoid your warranty. And if you so much as use a card and it goes on fire, you probably avoid the warranty too. So this is why we don't like free market capitalism here, or crony capitalism as they call it, where the shareholders get to control everything and they get the laws passed in their favor in order to control more and more of the decision-making process including whether or not the end product is a life hazard. And this certainly is a life hazard. Last thing, guys, especially for your RTX 40 cards, do not buy ATX 2.0 power supplies for them. I know they're on special, I know they're cheap as hell, but they're not a good idea. If you're going to buy a power supply, get something from Channel World Technology, number one. Those are the best OEMs for power supplies. Number two would be something like Anderson. Anderson makes pretty reliable supplies. They're fairly cheap though, so I don't really know if they make high-end ones anymore. But yeah, number three would be Superflower. I've had a few, but the experiences I had with them aren't that crazy good. But yeah, they're alright. I'd prefer them over whatever Corsair uses, which is Seasonic. And Seasonic's power supplies, I don't know, for me, when I build with Corsair, especially old or used Corsair power supplies and parts, they die really quickly, and I've just really stopped using them altogether for my builds. And really, the input lag actually is heavily affected by the stability of the power factor correction, and also the stability of the holdup for your voltages. Now, if you have a lot of ripple, or if you have a lot of hold-up time issues, then you're going to see them come across the board. Yeah, guys, avoid the power supply manufacturers that aren't officially making power supplies as their main product. Like, say, Be Quiet, right? Be Quiet has some strange OEM, I think it was HEC or something. But yeah, HEC is not crazy. It's honestly not even that good. These dark powers, they fail a lot. I've seen a lot of Be Quiets dead in the store. But these Gamdiuses are what we usually ship in our PCs, and these last forever. I've had about 100 and maybe 20 of these, and they just keep shipping out the door with no questions asked. Not a single return. Actually, the only issue I've had once was a fan was seized on the bearing, and the customer smelt a bit of, singeing plastic PVC smell. And I was like, yeah, that doesn't sound normal. So we took apart the power supply and just pushed the fan into there was a Teflon ring that I needed to snap into, and that snapped in and worked perfectly. So, very reliable product. I've never had issues with these. They never go dead on arrival. And it's really good for us because we want 100% uptime, especially for our customers. And so we have no troubles with returns. Anyhow, that's my 2 cents. Now this is the Gamdius N1 600 watt. They do make the 1000 watts. I haven't really reviewed those PCIE 5.0, ATX 3.0 capables. But yeah, you need an ATX 3 power supply, guys. So starting from the top, Thermaltake GF3. Do not get the GFA3. That thing is a literal scam. It will weigh half the weight of the GF3. I'm not even joking. Yeah, and it'll weigh a third of what a Corsair HX or RMX would weigh, and that's insane. So it's a 1200 watt power supply that weighs less than this dark power, like nearly half the weight of this dark power supply, and this is only a 850 watt, 850 watt power supply, and this is 80 plus titanium too. Even though that thing's gold rated, a GFA3, I think they really need to recall that product. It's a bad product. Thermalright's been caught in the act of anti-consumer again in another bait and switch. The last time I called out was, there was an issue with the advertising material once again. So they had ARGB on the fan in the picture, but when you actually got home and plugged it in, I know it didn't have the ARGB connector, but I thought at least a button would be able to do the rotating RGB, but no, it was a single color fan, and they absolutely scammed us for it, and my customer was not happy, and I was definitely not happy, but we let it slide because it was non-critical. So, well, you get me once, obviously, well, shame on me, but you get me twice, well, shame on you, isn't it? There's something wrong there if you want to scam your customers, especially when you do make a good product. Thermaltake has really, really good products every now and then. But the consistent thing is that every time I see a tough power come in the store, no matter how old it is, it still works, and it works beautifully. This is a 2000 and I think 8 or 9 model Thermaltake Tough Power, 1500 watts, no Japanese components, absolutely gronked out of the wazoo. It's got terrible ripple apparently, but it's got insane power factor correction, great hold up times, and it's a joy and a beauty forever. So if you want a good power supply, Thermaltake Tough Power has got you covered for anything from the low end to the middle range. Just get the Don't get the A3s, you can get the PF3s, but yeah, the PFA3 is a scam, don't get that. Second of all, EVGA makes pretty okay power supplies. They use Superflower, but yeah, Gamdius is definitely a recommendation from me, especially if you're on mid-range and you have an RTX, say 3060, 3070, going up to a 3070 Ti. They still ship like 750 watts for that kind of thing. But yeah, if you're going up to an i7 12th generation or i9 and above that, you're gonna need above 1000 watts 90% of the case here. This card here, a 4090, requires above 1200 watts. If you put 1000 watts, this thing will transient 1000 watts. It will not last. That power supply, even though it has the power excursion, no one knows what the specs are going to be like down the line. I mean, it's like a temporary kind of thing, yeah? How long is it rated to last? No one knows. And how stringent is the quality control of the spec? No one knows. Companies would vary from quality to quality, obviously. For usual power supply manufacturers, they always miss the mark on something. Even the best brands like Corsair or Asus, they do it all the time. MSI is actually fairly reliable. They're on Channelwell Tech. Thermaltake is on Channelwell Tech. Seasonic has dropped in quality a lot over the years, and they are not a warranty. Honoring a lot of their warranties, especially Asus as well, avoid like the plague these days, because people are saying that Asus is not warranting anything, and I know that too because I used to repair graphics cards with a mate, and every time the customers went to give warranty for their cards, say if they had just the card die by itself playing games, Asus would deny the warranty because they say, oh look, there's flux on the back of that's water, that's corrosion, you can't warranty that. And yeah, they deny the warranty, and that's a pain in the ass for the customer and for me, because now I have nothing to do with it, and they can't do anything, and they'll have to chase them up on the ACCC. Please get better, guys. Thermaltake is going to be my go-to recommend, and MSI as well, but Thermaltake has the best stringent quality control for that matter. Silverstone is okay. I think they also might use Channelwell, but yeah, Channelwell is pretty good. FSP is like a tier or two below that for Ripple and for regulation, but yeah, I'd say if you're starting out and you want a reliable power supply, especially for esports, get something that is double the TDP rating of all the components in your computer combined, and you should be sweet. Get the correct power supply, guys. Do not skimp on a power supply. That is very bad. Don't try to min-max your power supply, and a lot of that is getting into play here. The more faster your CPUs and RAM and graphics cards are going, the TDP rating is just absolutely a blatant lie. It's like loss factor in New York real estate. But obviously a lot of the business models now, especially from Corsair, is they last maybe 10 years. Only if you swap them out like 3 times, because they fail very fast and they rely on you not bothering to get the next one warranted. Here's the thing, when you look here, you can tell me what's wrong immediately, because here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 9, probably 10 or 11 Corsair water coolers here. They're all failed. Every single one of those had some blockage in them, or maybe degradation of the ring, the seal. It's nearly always the seal. Corsair is really bad organization, maybe on purpose, because I see consistently across all their products, they all have obsolescence pretty much built in. They have the worst quality RAM chips in terms of lifetime, and they do not last very long at all. These Vengeances, they only... I see a lot of dead ones, and they're really the only dead ones that come in are G-Skills and Vengeance LPX or Corsairs of whatever make. And yeah, obviously Corsair was a good brand back in the DDR3 days, but the DDR4 days and onwards, I don't know. Guys, don't feed the beast, don't buy 4090s. Just get a 4070 Ti, because that's really all the cable can handle here. And below that, you should be all fair game. Like, seriously, I know Galax is actually pushing out the bar here. They're releasing 2 power connectors on a lot of these cards. I think they're doing it for some of their 4070 series cards. or they're just using the 6 pins. And a lot of them on the higher end, like the Hall of Fames, they're getting too high power. So if you're getting really into the 4090 scene, get one of those. They're going to be a lot of a safer bet. And trying to cram everything through this. With a bit of carbon paste, you'll be avoiding house fire at home, hopefully. Hopefully it doesn't get that hot, and hopefully your power supply knows when to shut off. That's really all there is to it. Yeah, hope you enjoyed the video. Leave a like, and please drop a subscribe or something. Otherwise, I might drop your voltage in the power supply that you've got. So yeah, just remember, active PFC is very important, that you get a good PFC power supply. Thermaltake and Channelwell and MSI, they have the best designs for PFC holdup, and they are very, very dead stable for that kind of purpose. Input lag actually correlates very heavily with this kind of deal. A lot of people who live in rural areas of Russia and even western parts of Australia and Sydney have issues with power factor correction and high input lag out west. A lot of the time, you're probably just looking at a bad or crappy power supply. Even old Corsairs that used to be really good, or maybe just had really bad or inconsistent PFC circuitry that meet the standard but don't actually hold it up with a little jitter. That's the kind of thing you want to avoid, and well, anything that Channelwell OEMs and Anderson OEMs, they'll be pretty good. Superflower I think is not really as immune, but they're pretty decent quality too. So EVGA and Superflower are pretty much the same brand there, because they use each other's OEM power supplies. Anyhow, okay, that should be it. And for now, adios. I'll see you on the next video. Guys, come on, what is this? You look at the size of the connector on the left and the size of the connectors on the right. Those are literally half the surface area. Like, you can tell even by the plastic shroud alone. And the entire metal inside bit of this thing is going to be the same size as the entire plastic outside bit of this thing. And you tell me how this is going to ever fly. It's not. It's a fire hazard, and someone is going to sue them for a few $1 million, and they're going to lose out in a huge lawsuit like AMD did back in the day for false advertising. And obviously I don't stand for false advertising. Thermaltake got me once, got me twice, but they didn't get me again. I got the refund for the GFA3 and stopped it for the GF3, which is twice as heavy, surprisingly. And that's really concerning if it's 1200 watts. Whoa.